All right, we are still on a quest to be able to evaluate many different types of integrals. We're now going to enter into some that are trig integrals. At the end of this lesson, you'll be able to evaluate an integral that contains a sine and a cosine. And especially in this specific video, we're going to deal with when the power of the sine is odd and positive. So let's go ahead and look at an example. Well, actually, before we do that, a trig identity that we will be using is sine squared x plus cosine squared x is equal to 1, and that is a Pythagorean identity. So just keep that in mind as we do these problems. All right, so if you look at this problem, if the power of the sine is odd and positive, we're going to save one factor and convert the remaining to cosine, and then we'll expand and integrate. And as we get into the problem, that will start making sense. But if you look at this problem, I'd actually have to use the product rule to get this derivative, but I'd also have to get the chain rule, and it's going to get super duper messy. So fortunately, we do have a guideline to help us get unstuck on this problem without having to use integration by parts many times. So it tells us if the power of the sine is odd and positive, we're going to save, so notice we have a sine cubed, so that's odd and positive. We're going to save one factor and convert the remaining to cosine. So we're going to make this, instead of sine cubed, we're going to keep it sine x and then sine squared x. So notice we're keeping one factor. All right, and then we've got cosine squared x. Okay, and then it says to convert the remaining to cosine. So we're going to keep this one that we didn't just make as one factor, and we're going to convert it. And we're actually going to use, again, sine squared x plus cosine squared x is equal to 1. And if I solve that for sine squared, we'd have sine squared x is equal to 1 minus cosine squared x. So what I'm going to do now is substitute this identity in for that. So now I'm going to have the integral of sine x, and then instead of sine squared, I'm going to have 1 minus cosine squared x, and then I still have cosine squared x in my problem. All right, before I try to distribute this, I'm going to move the sine x over with the cosine just so that they're together. So now I'm going to have 1 minus cosine squared x times sine x cosine squared x. All right, the next thing that I'm going to do is now we're going to take this and we're going to distribute it into those parentheses. So now I'm going to have 1 times sine x cosine squared x will be sine x cosine squared x, and then minus cosine squared x times sine x cosine squared x will be sine x cosine to the 4th x. All right, the reason that we did that, because now that we just have one factor of sine instead of it being a power, we can actually do a u substitution with what the part that has a power on it, which is the cosine in both cases. So for both cases, I'm going to let u equal the cosine, and then du will equal negative sine x. And then in both cases, notice I do have a sine. I'm just missing the negative. Okay, so if I convert this, now I have negative the integral. This part, remember, became du, and now I have, this part was u, but it's u squared, so it's going to be negative u squared du, and then plus, this one will be, again, negative sine x was du, and this was u to the 4th, so we're going to have u to the 4th du. So now this just becomes a simple problem that I can take the integral of, so this will be negative 1/3 u to the 3rd plus 1/5 u to the 5th. And then just converting back to my x's, I'll have negative 1/3. U was cosine x, so it will be cosine cubed x plus 1/5 cosine to the 5th x plus c. And notice how much faster that went than actually me having to do integration by parts a bunch of times. So that's the guideline that we'll use for that specific problem.